Okay, so we have a couple more topics to cover before we are done covering material for our test. And our three topics are are going to be over isosceles triangles, creating triangles with triangle inequality theorem, and lastly, identifying the types of triangles by using the converse of the Pythagorean theorem. Okay, so starting off with our first topic, isosceles triangles are triangles that have two equal sides. So for example, I have a triangle like this with these two sides marked as concurrent. So an isosceles triangle is a triangle with two equal sides. And what this will also mean is that my base angles, the angles that are right below my congruent sides here, will also be congruent. Okay, so base angles are also congruent. So a quick example of what we can do with this is say maybe this side is 10 centimeters. If I say this side is x, then x will be 10 centimeters. Same thing for my angles. If I tell you that this is y, and I tell you that this angle is, say, 50 degrees, then y would be 50 degrees. And there is one more thing that we can do with this, and that would be by giving you an isosceles triangle, where we give you the top angle instead of the base angle. So if I tell you this top angle is 100 degrees, then these two angles, x and y, would then take our full triangle of 180 degrees, like this. And we can split the remaining 80 degrees into two parts, which will give me 40 degrees each. So both x and y angles will be 40 degrees. This pretty much covers most of the things we can ask you with isosceles triangles. The most important thing is to identify that your triangle is an isosceles triangle. Okay, so moving on, we have our triangle inequality theorem. Triangle inequality theorem. And this is a theorem that essentially states that can we make a triangle? And at first glance, it seems sort of obvious. I mean, what do you mean, can we make a triangle? Well, if we have lengths using lengths, maybe like 2, 3, and 30, for example. So this would end up looking like I have a super long line. This is 30. And then I have two more lines that are too long. And I cannot complete this triangle because these two sides of 2 are too short. So these two shorter sides cannot meet, and therefore we cannot make a triangle. Okay, so if we extend these lines out a little bit more and maybe use lengths something like 15, 15, and 30, it would seem as if though it should be able to meet. But when we do draw this, or maybe try to manipulate like things in real life of similar length, you would end up having a triangle that looks like, probably make this a little bit longer. You'd end up having a triangle that looks like this. where these lengths are both 15, but we are just a little bit short here. Okay, and in the case that our sides of 15 do touch, so instead of being separate like this, if we had a straight line where the two 15s touch at this point, then it would be completely parallel to my side of 30, or on top of each other, in which case we no longer have a triangle. So maybe this line is straight on top of that other 15. Okay, so at the very least, it seems like while observing here, our two shorter lengths need to be a little bit longer than 30. So with two sides of 15 and 16, then they should be able to touch because one of these lengths goes a little bit past this halfway point, and my two shorter sides can meet. So if you have not realized or observed by now, we can create a triangle as long as a triangle is possible when the two shortest sides sum up to be greater than the longest side. So here we had 15, 15. If we add these together, that gives me equal to 30, which doesn't work. But here we have 15 plus 16, which gives me 31. And this 31 is greater than 30. So this is where a triangle is possible. So some examples of lengths of triangles that may or may not work would be something like 1, 2, and 3 would not create a triangle. No triangle possible because 1 plus 2 is not greater than 3. We can do something like 3, 3, and 3. This would be yes, triangle is possible because 3 plus 3 is indeed greater than 3. And in fact, if you notice, this would be an equilateral triangle. I don't know how to spell equilateral triangle, because all of my sides are the same. So speaking of equilateral triangles, we can go into this a little bit more later. Okay, so we'll keep this in mind in a second. All right, so our last topic here is over the converse of the Pythagorean theorem. And you're probably sitting here wondering what that is. How would you flip the Pythagorean theorem around? Well, our Pythagorean theorem tells us that a squared plus b squared is equal to c squared in a right triangle where our legs a and b and our hypotenuse is c. Except it talks about a very specific type of triangle. It talks about a right triangle. So this has to be 90 degrees. This talks about a right triangle. So the Pythagorean theorem always talks about right triangles, except when we have sets of numbers, they don't always have to be right triangles. So if we do something like 3, 3, and 3, we know we'll have a equilateral triangle. So if all three of these sides are the same, we'll have an equilateral triangle. And a equilateral triangle is also a acute triangle. So here we'll have three different types of triangles. We have our base acute triangle, where all angles are acute. We have our obtuse triangle, where at least one, this is my obtuse angle, where you can't have more than one obtuse, where one angle is obtuse. And lastly, we have our right triangle, where one angle is 90 degrees. And in case you forgot what acute, obtuse, and right are, acute is when you have an angle that is less than 90 degrees. Obtuse is when you have an angle that is greater than 90 degrees. And a right triangle is when you have an angle that is exactly equal to 90 degrees. Okay, so earlier we said if we have an equilateral triangle, we have an acute triangle. Okay, and when we have a right triangle, when we have a triangle with a right angle, it's 90 degrees, and our Pythagorean theorem talks about a 90-degree angle. So I'm sorry for rambling, but essentially here we have the Pythagorean theorem, where a squared plus b squared is equal to c squared. But in an equilateral triangle, a squared and b squared are both 3, and c squared is 3. And it's most definitely not equal. So what actually goes here? So when we take a look at this, by actually doing the math, 3 times 3 is 9, or 3 squared is 9, plus 3 squared is 9, some relationship with 9. So 9 plus 9 is something with 9. Well, the most obvious thing we can put here is greater than 9. Remember that this was an equilateral triangle. Also remember that an equilateral triangle is a acute triangle. So essentially, if this sides A and B squared and added up together are greater than my third side, then I have an acute triangle. And then the other way around, if I have two sides that add up, like 3, 3, and 5 squared, and happen to be less than my third side, then this would end up giving me an obtuse triangle. And then lastly, we have our, if my 3 sides are equal when put into the Pythagorean theorem, then I most definitely have a right triangle, since that's what the theorem originally was intended for. Okay, so put it simply, acute triangle will be found when you have a squared plus b squared that is greater than c squared. A obtuse triangle will be found when you have a squared plus b squared less than c squared. And a right triangle will be found when you have a squared plus b squared equal to c squared. And don't forget that all 3 of these c's are always referring to your longest side. It only happens to be called the hypotenuse for our right triangle, because otherwise it is only referred to as the longest side. So longest side is equal to C. please keep that in mind.